Good afternoon, class. After the first chapter completion, we are going to start the new chapter, that is acid, base and salts. In the previous chapter, very few doubts I got. So assuming that everyone is clear with this chapter, in the first chapter, the main concept was about the balancing and types of reaction. So you should be very careful while balancing and by knowing the chapter types of reaction. So today we are going to start the new chapter, that is acid, base and salts. Acid, base and salts. So one by one we will go through with this. First we will do that acid, base, and then at last we will do the salt. Okay, so if we go through this acid actually it is a term which is derived from the word acidus. Okay, derived from a word that is acidus. Acidus means, what do you mean by this acidus? It means sour taste. Okay, so the one which is sour in taste is known as acidus. It doesn't mean that everything which is sour in taste will be considered as acid, but yes, acid has the taste this. Okay, example, if you see lemon juice, or we can see curd, vinegar, sometime grapes also, you can see grapes khatta, okay, like green apple. Yes, these can be the example. They have sour taste. Okay, so they are acidic in nature, but only this sour taste doesn't say that these are the acidic in nature. Okay, so what another thing, how to identify? But the first is sour in taste. Okay, and second thing, if we have to identify that whether this given example is of salt or not, we have to do that litmus paper test or pH test. Okay, so litmus solution test and litmus paper test दोनों होते हैं. So litmus test if we are doing, so if we will add litmus acid, we will turn the litmus solution, into red. Okay, if in any chemical substance, whatever, like in lemon juice or curd or vinegar or grapes juice, okay, if we are adding this one or two drop of litmus solution and the color of that solution becomes red, okay, then we'll say yes, it is it is acid, while base will convert it into blue. So we'll do afterwards. Okay, there are some, like one is litmus test, another is phenolphthalein. Also we can say the phenolphthalein, methyl orange, they are the indicator. Okay, so let me write this thing, that acids, I'm talking about the acids, these are the acids actually, are colorless with phenolphthalein. Okay, but pink with methyl orange, pinkish orangish, we can say methyl orange. Actually what it is, phenolphthalein and methyl orange are the indicator. Litmus is also indicator. Okay, these are the indicator. Indicator means it explain that whether it indicates whether the substance is acidic or basic. So if we will add phenolphthalein in that substance and there is no change color, that means there is no change in the color, and yes, we will say it is acid. And if we are adding methyl orange and the color of that solution changed to pink or orangish, so we'll say yes, it is an acid. Got it? Okay, so there are many substances in daily life, like tamarind we use, lemon we use, something. So these are sour in taste and they are acidic. So now if we talk about the classification of acid, acids. So acids definitions can be defined. It has three concepts. The first concept is Arrhenius concept. The second concept is Bronsted-Lowry concept, and the third one is known as Lewis concept. Okay, so in class 10th we will do this Arrhenius concept and bit of Lewis concept, but not this we will do in class 11th. Okay, and this is bit of this Lewis concept we will do it here. So what this Arrhenius concept? So let me write this Arrhenius concept. Arrhenius concept. It says that any substance which releases H plus ion, okay, H plus ion is known as H plus ion when dissolved in water. When dissolved in water is known as acid. Got it? This point I have left, I will explain it afterwards. Okay, so any substance which releases H plus ion when dissolved in water is known as water. So the two things important: releases H plus ion and when dissolved in water. Got it? So that means acid cannot behave as an acid until or unless it is dissolved in water. Got it? So when it is dissolved in water, then only it will release H plus. So acid, to show the acidic property, the substance must be dissolved in water. Got it? So this is Arrhenius concept. Now this H plus can also be considered as proton. Why it will be proton? How? See, if we talk about H, so this is 1 1, yes, and if class 9th concept, if you can remember, you can recall that this is atomic number is 1, isn't it? If atomic number is 1, it is having proton 1 and so of electron is 1, isn't it? But what about the neutron? Neutron is 1 minus 1, A minus P, so it will be 1 minus 1, that means 0. So it has only proton and electron. Got it? When we talk about this H plus, that means plus charge, that means it has lost its one electron. Yes. So if one electron is lost, so now only proton is 1, but electron becomes 0. Got it? So that's why this H plus can also be considered as proton only, because it has only proton, isn't it? Clear? So we can define it: any substance which releases H plus ion, or you can say proton, got it, when dissolved in water is known as acid. And these substances are also known as these means which releases H plus ion. Okay, these substances are also known as protic acid. Protic acid, that means which releases H plus proton. Clear? Okay, so now if we talk about that, this is protic acid. Okay, so and now next topic in this only, we have to do that basicity. See, this concept is little different. Basicity of an acid. Whenever we talk about the acid, it has basicity, and whenever we talk about base, it will have acidity, just opposite. Got it? Acidity will be for base and basicity is for acid. So how can you define this basicity of an acid? The number of H plus ion released by any acid in its dissolved state. Dissolved means water dissolved state. Okay, dissolved state is known as basicity of an acid. Basicity of an acid. Clear? Okay. So if there is HCl, suppose that is HCl, whenever we dissolve in water, this split into H plus and Cl minus. So how many H plus it is giving? 1. So what is the basicity for this? Basicity for this? 1. So this can also be called as monobasic salt. Monobasic acid. Clear? And since 1 H plus, this H plus can also be called as proton. So 1 H plus 1 proton it is donating. So that's why it is also known as monoprotic. Hope it is clear. Mono means 1 and basicity is 1, so that's why it is known as monobasic. And since it is losing 1 H plus ion, so that's why it is monoprotic. Another example, if we do H2SO4, when we dissolve in water, this gives H plus and HSO4 minus. Got it? Or you can directly, or further dissolve, it will give another H plus also because it has 2 H plus. So in the same way we can write 2 H plus and here SO4 minus 2. Got it? You can write in this way. So how many H plus it is losing? 2. How many? So this is basicity is here 2, isn't it? So it will be called as dibasic acid. Okay. And since 2 H plus, that means 2 proton it is giving, so it is also known as diprotic acid. Clear? Third example, let me do this H3PO4. If we do this, dissolve it, this will give, this is having 3H plus plus PO4 minus 2, isn't it? So what is the basicity here? Basicity is here 3, so it will be considered as tribasic acid, or you can say triprotic acid, isn't it? Protic acid. Okay, so by this example we can see that whatever H plus is there in the compound, that much is the basicity of that compound. Yes, 1 here, so that's why 1 basicity, 2 here, so 2 basicity, 3 here, so 3 basicity. There are few exceptions that you have to, 2 exceptions only you have to learn. Exception. Although this will not come in your class 10th question book. This is H3PO2 and another is H3PO3. Although it is having 3 hydrogens, so it seems that it will lose 3 H plus, but no, it doesn't lose. Okay, its basicity is only 1. Basicity is only 1, and this is having 3 H, but for this also this is not 3, it is 2 only. Got it? So this will be explained on the basis of their structure. It will be little deep here, so that's why I am leaving this topic by explaining this. Okay, will do. If anybody interested, you can ask personally, I will explain it. Okay, but just for exception you have to learn, although it is having 3 hydrogen, but it doesn't give 3H plus, it gives only 1. Basicity is 1, and here also 3, but it gives only 2, so basicity is 2. Got it? Okay, so after this Arrhenius concept, as I said, Bronsted-Lowry concept we will do in class 11th. Now Lewis concept. Okay, so see, there are so many like Arrhenius explained the acid which can give H plus only. Okay, but there are still many acids are there which don't have H plus but still they are acid, like CO2. Okay, so there is no hydrogen, so it cannot give hydrogen, isn't it? But still it is acidic. So how? Like AlCl3. These are the few examples which, like BF3, like what we say BeCl2. So these are the so many compounds are there which don't have hydrogen. That means if they don't have hydrogen, they can't give hydrogen, and if they can't give hydrogen, they cannot be considered as the acid, but still they are acid. Got it? So although they don't have H plus, but still considered as acid. Yeah, but still show acidic property. So how come? Like Arrhenius concept is fail over here. Acidic properties. Okay, so next concept came property. Next property came next method concept came Lewis concept. So this Lewis concept for acid says that the electron deficient compound, what it is I will explain. Wait, electron deficient compound and all the positive charged group or compound, positive charged group or compound are considered as Lewis acid. Okay, because electron deficient, they are electron deficient. If any compound is having positive charge, it means it is not its octet is not complete. Octet kya hai? Now the question will be that what is octet? So just I am giving you brief knowledge about it. There is a concept that the element should have 8 electrons around it, 8 electrons or 4 bonds around it, then only it will be considered as stable. Got it? What I said? The elements should have either 8 electrons, anyhow you can check, 8 electrons, or they must have 4 bonds. Okay, or combination of these two, मतलब total 8 होना चाहिए. Got it? Then only they will be considered as stable. If we draw the structure of AlCl3, aluminium 1, there are the 3 Cl, so we will make the 3 bond over here. So how many bond is there? 1, 2, 3. What I explained? 4 bond, at least 4 bond होना चाहिए. So there is only 3, so that means it is electron deficient. Got it? Similarly BeCl2, if you do, this is BeCl like this, so only 2 bonds, should have 4 bonds but 2 bonds only. So this is again what we say, Lewis acid. Okay, and the positive charge group or compound like H3O plus, although it is having H, but if it is positive charge, it will be considered as Lewis acid. Got it? Like NH4 plus. Okay, so these are Lewis acid. They are called Lewis acid. Okay, examples above mentioned jitne bhi hain, like BF3, you can write AlCl3, BeCl2, NH4 plus, anything, H3O plus. These are Lewis concept, Lewis acid. Okay, so now another classification, like one we have done by this concept. Okay, another based on sources. Classification, 1 second, this is 1, if I am marking it here. This is 2. Classification based on sources. Classification based on sources, that means from where it is obtained, based on their sources. What it says? It says that plants are like acids are of 2 types. One is organic acid and another is inorganic acid. Okay, so on their sources they are of 2 types. One is organic acids and another is inorganic acids. Okay, organic acids are like such acids which are present in animals and plants. Okay, all the acids which are present in present in what we say, living organism, we can say living beings like plants and animals, present in plants and animals. Okay. Another, all that chemical is synthesized, or sorry, inorganic, all that acid which form in the rock or the minerals, okay, they are. So all the acids obtained from rocks or and minerals, rocks and minerals. So that's why inorganic acids are also known as, that's why inorganic acids are also known as mineral acid. Mineral acids. Got it? So another, you can say organic acid, that means they must have carbon. How you'll identify? So they must have carbon, and such acid in which carbon is not there, without carbon. All the inorganic acids will be without carbon. Got it? And since they are present in plants and animals, so they should not be strong. Okay, so actually they are weak acid. They are weak acid, while they are strong acid. Generally they are strong acid. So let's do some example. Strong acid, if you see the carbon, okay, it will be considered as organic acid and it will be weak. Example, like if I'm doing CH3COOH, so can you see the carbon over here? Yes, carbon is here, so that's why it will be organic. If we take an example like H2SO4, can you see the carbon over here? No, so it is inorganic or mineral acid. Like HNO3, is there carbon? No. In this example, like HCOOH, okay, so these all are weak acid, organic acid, and these are mineral acid, inorganic acid and strong acid. Got it? Now based on third point, we will do classification based on ionization. Classification based on ionization. What is this ionization? Ionization, that means conversion, or the tendency to convert it into ions or ions form. Okay, so on this basis there are two types. One is strong acid and one is weak acid. Okay, so actually strong acid, what it will be, they will completely ionize. Okay, they will ionize completely, like whatever number of hydrogen ion are there, they will give as a H plus. Okay, they will ionize completely, while in this case they don't ionize completely. They don't ionize completely. Okay, so if they are completely ionizing, they will be called as strong acid, and if since it is not completely ionizing, so that's why it is weak acid. Okay, so example is same. Weak acid, that means organic acid, and strong acid, that means mineral acid. So you can write that H2SO4. How you'll see? How many hydrogen here? 2. So on ionization it totally give 2H plus, it completely give. Got it? Like HNO3, on ionization how many H? 1. So it completely donate. Got it? But if we talk about weak acid, like this is CH3COOH, so how many hydrogen here? 4. It should give 4, but actually it doesn't give 4. It ionizes in this form, CH3COO minus plus H plus. So although it is having 4 hydrogen, but it is giving only 1. So that means it is not completely ionized. Okay, like HCOOH. The one which is attached with this oxygen, that hydrogen will come out. Okay, be careful. Not this. The one which is attached with the oxygen, that will come out. Okay, so in this case it forms HCOO minus and H plus. Clear? So on this basis we can say strong acid and weak acid. Now again the fourth method is classification based on their concentration. Classification based on concentration. That is again of two type. Okay, one is dilute and another is concentrated. So we'll write here, let me write in this way only. The one is called dilute acid and another is called concentrated acid. Okay, what is mean? Like acid can behave as an acid only when it is dissolved in water. Okay, so if the amount of water in that solution, in that acid, is more, got it? If the amount of the water is more in that acid, then it will be considered as dilute acid. And if the acid content is more than the water, then it will be called as concentrated acid. Got it? So we can write, if amount of acid is very less in comparison to water, then it is called dilute acid. And here amount of acid is more, in comparison of water present in that, then it is called concentrated. In comparison to water, then it is called as concentrated acid. Got it? Okay, after this there is a question, index question in your page number 18, that you have been provided with 3 test tubes. One of them contain distilled water. Okay, another is and the other 2 contains an acidic solution and the basic one. One is acidic and one is basic. So what I am saying, one is distilled water, one is acid, one is base. So mark it as A, B and C respectively. If you are given only red litmus paper, okay, only red litmus paper is given to you, then how will you identify the contents of each test tube? Okay, so how you will identify A, B and C? What is that? So what you will do, in this mark it as put it in 3 beakers, A, B and C, and mark it as like this, A, B, C. Okay, and with the help of dropper, just put a few drops of A on the red litmus paper. Okay, like this. If this litmus paper, if the litmus paper shows no change in color, okay, then it will be neutral. Got it? Okay, the whatever, like you have taken drop from, like if you have taken A from drop from A and put it on that litmus paper, and you have seen that there is no change in color, so what it will be? It will neutral. In another test tube, like one test tube is one beaker is done with that, so you identified that A is what? Distilled water, isn't it? Because distilled water, there is no change color, so that's it, that is neutral. Okay, it is neutral, it comes neutral. Now in any one of that, suppose that I have taken drop from B. Okay, this is drop from drop from A. Now suppose that in this drop from B I have taken, from B, and the color of this litmus paper change into blue. So and litmus paper, we have checked that litmus paper changed into blue color, changed into blue color, got it? So then if it change into blue color, then it will be basic, got it? The litmus paper turn into blue, it will be basic. And so what left? C. So put the C drop of C test tube on another litmus paper, drop from C, and the litmus paper changed into red color, okay, red color. So then it is acidic. It can be any way, like I have taken A, B, C, like A is distilled neutral, B is basic, and C is acidic. You can do maybe the one which shows red color on the litmus paper will be acidic, the one which is showing blue color on the litmus paper will be basic, and the one which is not showing any change in color, it will be neutral. So maybe you placed in that beaker test tube, maybe the drop from the C will not show any color. So the one which is not showing any color change will be neutral. Got it? It's not like that in this way only. You have to check that 3 test tube you are supposed to, like you got any randomly, you are taking the drop from any beaker, any test tube, and put it in the litmus paper. If litmus papers change into blue color, you will say it is basic. If that test tube, that drop from the test tube shows red color, it will be acidic, and if there is no change, it will be neutral. Got it? So this is your in-text question. In-text question, page number 18. Okay, now we have to do the properties. I think, one second, let me check the topic. Yes, next topic is chemical properties of an acid. Chemical properties of an acid. It is important. Again, the reactions will be there, so understand it properly. First we will do reaction of acid with metal. Reaction of acids with metal. Okay, so that point it will work till class 12th and 11th also. So see, if any substance, if it reacts with metal and it is liberating H2 gas, that substance will be considered as acid. So in that way I am writing acids when react with metal, liberates H2 gas. Okay, so how you will identify that H2 gas is liberating out? So that can be see, gas is evolving, that you can see by the bubbles. Okay, bubbles will be there, so that in that way you can say it is gas is evolving. But which gas, H2 or carbon dioxide or oxygen gas, which gas is evolving out, that will be identified by, that can be identified or confirm, you can write identified by pop sound when a burning matchstick is brought to the mouth of the test tube, Okay, so if you will, this is the lab work we will do in the lab also, this work. So when that H2 gas is evolving out, how can you identify, how can you confirm? you have to, what you have to do, you have to bring a burning matchstick on the mouth of the test tube and just listen silently. You will get pop sound. Okay, so let's do some reaction with this, like Zn. Okay, example, Zn plus HCl, it will give you ZnCl2 plus H2. This H2 gas will be identified by pop sound. Like another example, you can try it, Na with this HCl, what it will give. So to balance it, we have to make it 2 over here. This one, to balance it, we have to do like this, 2 NaCl and H2. Okay, now another example, you can take calcium plus H2SO4. Okay, this will give you CaSO4 plus H2. Got it? So these gas can be identified by pop sound. Now you have to there is some important point in this. See, any acid, it can be any acid like H2SO4. So there is an exception point, exception, like if we do this reaction instead of this HCl H2SO4, if I am taking Zn plus HNO3, got it? So what it should give? Zn NO3 and whole twice. Why? Because NO3 is -1 charge and Zn is having +2, so cross formula zinc nitrate will be this. And according to that, whatever I have written, accordingly, whenever any metal reacts with any acid, it should liberate H2 gas, but it won't liberate H2 gas. It will, instead of that H2 gas, it is liberating H2O. Got it? That means with this HNO3, H2 gas is not liberated in general. Okay, except, see, with HNO3, note, write on, you can write in note, with HNO3, except Mg, magnesium and Mn, manganese. Okay, except magnesium and manganese, other metals with HNO3, except this metals, other metals produce H2O instead of H2 gas. Now you can ask me why it's so. So actually क्या होता है, reason behind it is HNO3 is a strong acid, is a very strong acid which oxidizes H2 gas in H2O. Got it? That means whatever the H2 forms, this HNO3 oxidizes it into H2O. So if we do this reaction with this any other metal, it will give you H2, except manganese and magnesium and manganese. They will liberate as H2 gas only. Okay, so this is very important point you should keep in your mind. Like if we do this reaction with this Na plus HNO3, then also what it will do? HNO3 is a strong acid and this is not manganese, this is not magnesium, so it will form NaNO3 and H2O. Got it? Clear? Okay, tell me one thing. I will do it afterwards. Now if I am using Mg plus HNO3, what will be the product? In this case it is magnesium, so this will to form MgNO3, and since again the magnesium is +2, so this will be the formula and it will give H2. with this manganese and magnesium and manganese, it will liberate H2 gas only. But rest other metal, if it is there, HNO3 will convert into H2O. Got it? Pause the video again and again and try to understand properly this point. Okay? If still there is any doubt, you can ask. If I am using Mn plus HNO3, what will happen? This is again Mn, exceptional case. So in this case also, it won't form water, it will give you H2 gas. Okay? Clear? Now, one equation if I am asking, what will happen if Cu reacts with this HCl? Will it form CuCl2 and H2? Yes? Will it form? It won't form. What is the reason behind it? The reason is that as copper is less reactive than hydrogen, so can't displace it, so can't displace it from its solution. If you can recall that, in the previous chapter we have done the reactivity series, and there I have told about that copper is below hydrogen, isn't it? This is another equation. So yes, it will liberate H2 gas, the reaction will occur, but the metal should be more reactive than the hydrogen. Got it? Except magnesium and magnesium and manganese, all other metals with nitric acid gives H2O instead of H2. Got it? So this is very important point. You have to understand it properly. Okay? Okay, so after this, next thing we will do that rest chemical properties of an acid we will do in next video. Okay, and by the time you are supposed to do the homework, that is NCERT back exercise question number 5, 6, 7 and 8. Okay, these are the 4 questions that you are supposed to do in your notebook, and just watch the video properly, write the notes them and do these questions. Okay, so hope you will get it, hope you will understand whatever I have explained. If there is any doubt, you can ask. Till that, okay, thank you class.